Welcome to this explainer. Today, we are going to dissect the absolute unsung hero of a comfortable ride, the Novin Puya Elevator Guide Shoe, specifically focusing on the economy model. You know, when we step into an elevator, we just kind of expect a smooth, quiet ride straight to our floor. But making that actually happen? That requires some serious, behind-the-scenes mechanical engineering. So let's get right into it and uncover exactly how this crucial component gets the job done.
I want you to think about this question for just a second. What keeps an elevator from violently shaking as it rockets up and down a dark shaft? It's super easy to view elevators as everyday magic, but they rely heavily on some very real, hidden mechanics down in the shaft. Without the exact right hardware, every tiny bump or slight misalignment in the tracks would literally be sent straight into the cabin, rattling your teeth the whole way up. Okay, let's dive into this. A guide shoe is essentially the intermediary between the elevator cabin and the rails it travels on. These are absolutely crucial components that transfer lateral or side-to-side forces, all while maintaining the precise vertical alignment of the cabin and the counterweight. Before we get too far into the engineering weeds here, it's super important to establish this fundamental purpose. They are basically the steering wheel and the stabilizers for the entire elevator system.
Here is our roadmap for today. First, the secret to a smooth ride. Second, we'll go inside the economy shoe. Third, we'll look at the spring-loaded mechanism. Fourth, the strengths and limitations. And finally, a quick installation and maintenance guide.
Starting with Section 1, the secret to a smooth ride, and what I like to call the economy misconception.
We really need to address a misconception right out of the gate here. When we say economy in the context of the Novin Puya Guide Shoe, it absolutely does not mean a compromise on safety. No way. This model optimizes costs without lowering those rigorous safety standards. It's not just a one-size-fits-all part, it's specifically designed for standard residential or mid-traffic projects. So, instead of using highly complex and really expensive roller guides, it relies on incredibly efficient sliding mechanics. It's a targeted, smart engineering choice for specific buildings. I mean, you wouldn't put a Formula One racing tire on your reliable daily commuter car, right?
Moving right along to Section 2, inside the economy shoe, we're going to do a bottom-up teardown.
Let's do a macroscopic teardown to see exactly what makes this hardware tick, starting from the outside and working our way in. First up is the base body. This outer shell is built from galvanized, bent sheet metal or light cast iron. Why? Because it drastically reduces the overall system weight while still holding on to the rigid strength you need to absorb lateral impacts. Plus, that galvanized steel body provides absolutely crucial corrosion resistance. Elevator shafts aren't exactly cozy, climate-controlled living rooms, you know? They're often semi-moist environments, and this metal is specifically treated to survive down there.
Now, what's really interesting here is what sits inside that metal body. The inserts, or liners. These distinct green polymers act as the true friction barrier between the heavy metal of the elevator and the heavy metal of the rail. They're typically made from high-density polyethylene, or HDP for short, and sometimes self-lubricating engineering nylon. This right here is the beating heart of the Novin Puya economy model.
Let's look a little closer at why HDP is the material of choice. First off, its self-lubricating properties drastically reduce the need for constant manual maintenance. But if you look at the design itself, you'll notice it has a grooved surface. This isn't just to make it look cool. This specific groove design optimizes fluid dynamics. It effectively distributes oil if the rails are lubricated, while simultaneously reducing the effective contact area. Less contact area just means less chance of the shoe sticking to the rail when temperatures start fluctuating.
According to the engineering specs, 0.5 to 1.0 millimeters is the exact target. To all the technicians listening out there, you know exactly how critical this is. The bolt and nut connection on these economy shoes allows you to dial in this precise clearance standard. Getting this specific spacing perfectly right is the magic that allows the shoe to glide effortlessly without rattling loosely all over the place.
All right, Section 3, the spring-loaded mechanism. Basically, the elevator suspension.
The dynamic physics at play are really the secret weapon here, and the mechanics brilliantly illustrate this. The spring-loaded mechanism essentially acts just like a car's suspension system, absorbing bumps on a rough road. A completely rigid shoe just drags along the rail, so if there's a bump, the cabin feels that bump. But behind the moving arm of this shoe is a coiled spring. That spring allows the insert to flex and maintain constant, controlled contact with the rail, even if the rail has microscopic imperfections.
To quote the engineering breakdown directly, the spring mechanism absorbs energy at fishplate joints, preventing shocks from transferring to the cabin and minimizing vertical rattling. In case you're wondering, the fishplate joints are just the spots where two rail segments meet. By letting the spring take the hit, this shoe provides a premium, smooth feel for passengers, but it pulls it off on a highly efficient budget. It is a fantastic example of using simple mechanics to solve complex comfort problems.
On to Section 4, Strengths and Limitations. Let's look at the engineering reality.
Of course, no piece of engineering is perfect for every single scenario, right? Understanding these trade-offs is crucial. On the strength side, you have incredibly easy maintenance, cheap insert swaps, spring-loaded noise reduction, and a really optimal balance of price and performance. However, there are limitations. It is simply not a magical device for high-speed skyscrapers. It has a strict maximum speed limit, it's going to experience higher wear rates in very tall buildings, and it absolutely demands perfectly clean rails to function well. The takeaway? It is highly cost-effective, provided it is used in the right building.
So the crucial point here is that speed limit, 1.6 meters per second. Exceeding this speed generates excessive frictional heat, and because the inserts are made of polymer, which is essentially plastic, that heat will physically deform them. Actually, it will completely melt them over time. This is a hard engineering boundary regarding the heat resistance of the HDPE. If your elevator needs to go faster than 1.6 meters per second, this is for sure not the shoe for you.
Let's wrap up with Section 5, Installation and Maintenance Guide. Here are your actionable takeaways.
Focusing entirely on practical application, there is a strict chronological sequence to getting the maximum efficiency and lifespan out of this part. Step 1, pre-tensioning the spring. Step 2, ensuring precise alignment. And Step 3, applying proper lubrication. Let's break these down quickly.
Step 1 is pre-tensioning. The spring behind that articulated arm must not be too tight, or it will clamp down hard and cause cabin jams. Conversely, it can't be too loose, or it completely fails to absorb any vibrations. Finding this perfect tension sweet spot, getting that normal seat on the rail, is literally the difference between a buttery smooth ride and a terrifying shaky one. Step 2 is alignment. Because this shoe features an articulated joint, the green inserts must be perfectly parallel to the lateral surfaces of the rails. I have to warn you though, because of the shoe's simpler, economy structure, the smallest plumbing error in the rails leads to immediate, uneven, asymmetrical wear on the polymer insert. If it tilts, it will grind, and it will fail way before it should.
Step 3 brings us to lubrication. If your system requires it, use standard elevator oil with the appropriate viscosity. But hear this urgent warning. Please, whatever you do, never use heavy greases. Heavy grease acts exactly like a magnet. It attracts abrasive dust and floating particles in the shaft, creating a sandpaper-like paste that will rapidly destroy that green polymer insert. Keep the heavy grease far, far away from the economy guide shoes.
To quickly summarize the ongoing maintenance cycle, ensure the shoe is properly matched with compatible T5, T9, or T16 standard rails. Inspect the wear on those polymer inserts every 6 months. Remember, super cheap and easy to swap out, so catch them before they fail completely. And finally, maintain absolute rail cleanliness. Facility managers, listen up. Your ongoing maintenance costs can stay incredibly low if and only if you follow these basic rules of the trade.
And that brings us to the end of our breakdown. I'll leave you with this thought to mull over. Is your building using the right guide shoe for its specific speed and traffic? Or are you paying for unnecessary wear and tear right now because of mismatched hardware? Next time you step into an elevator, take a moment to appreciate the hidden engineering, the quiet suspension, and those little green polymers working tirelessly in the dark to give you a smooth ride. Keep learning, keep asking questions, and I'll catch you on the next explainer.